Okay, we are back with yet another example from MyMathLab, and this one is an application of functions. We said that functions can be used as models, in this case, business models or models from study of economics. Very, very oversimplified example, dealing with a cost function and a revenue function, and a very simple topic in terms of business. Businesses are exist to make profits, right? There's no sense in doing anything, putting forth that time and effort if you're not going to make a profit. Okay. And so times these again are pretty simple. We have something we're just calling a product, and we're talking about the number of units. So X would be the number of units of that particular product. And if we just substitute in here, in other words, X is one, we sold one unit, the money that we're going to bring in is 600, assuming we're working with dollars here, $600. We sell two units, we get $1,200 and so forth. So for every unit, we're bringing in $600. However, there's a cost here for that. And that cost, again, could be for the machinery, the manufacturing, the workforce, all that other stuff is, we leave that to, statisticians or someone that, else to come up with this cost function. Okay. So again, for one unit, just making one of those things, we're going to pay $12,360 plus an additional 480. Okay. So, it wouldn't benefit us, right? Because it's costing us way more to make one unit than the revenue that we would bring in. Okay. So we obviously want to find here in this case where we're going to break even, and then wherever we break even, we got to hope we're going to sell a lot more than those to make it worth our while. We also have another parameter here, which is said that for whatever reason, the market's not going to, we're not going to be able to sell any more than 292 units. Okay. So, this might be, if we try to put it in context, some very high-end product that's going to be very expensive, it's only going to be a very small market of people that can possibly buy it, as well as, wanting to buy the thing. Okay. So anyway, so 292 units is our maximum here. And so what we want to do is we want to go ahead and answer this question here based on this multiple choice option here. Is it says if the company can produce and sell no more than 292, should it do so? Okay, so that's where we're going, and the choices here, obviously, since 292 is less than the break even. In other words, if we sold all of the possible units we could, um, we're not even going to break even. So obviously we wouldn't want to do that. And that since 292 is greater than that break even, again, we cannot again produce a profit here, okay, because we're not in that range, okay. And so that that would kind of throw that out. And obviously the two yeses here, it says yes, 292 is the break even, is equal to the break even production of the product can produce profit. Okay. So, it's, that's doesn't make sense, right? Because at 292, we would just be, so we wouldn't want to choose that. So this obviously is the best case scenario. So, we're going to see if this interest or this situation exists, which it does. That is the correct solution here. Okay. Because the break even is 103. Okay. So at 103 units, we're going to break even. I'll show you how to get the 103 here in a second. But I'm just trying to put this in the context of how models work. All right. So so anyway, let's kind of go in here. We can do this algebraically. I'm going to choose the graphical technique, but we do have to use some algebra here to get the profit function. And I'll just talk about that real quick, right? The profit is just going to be how much we bring in minus whatever our cost is. So if I just substitute in the expression 600x, which we get for the revenue, and subtract from it this whole quantity. So I got to make sure I should have used my right parenthesis here. when I distribute that -1, I'm going to get 600x minus 480x, which is 120. And then that's just going to leave me with a negative 12,360. And that's what goes in here. But I would have to enter these numbers in first. And I don't even think you can type this in until you answer these questions. Okay, so this is just a still shot of the problem completed. All right, so how do I come up with 103? Okay, that's the big thing, which will yield me to part C here, okay, which is, again, the 292 is greater than the break-even point. So, I'm going to have, like make money if I sell anywhere from 104 up to 292 units, okay? And so where's that come from? Well, here I'm just going to enter in using the notation R of X here for my revenue and C of X for my cost function. And notice if I'm just in this window here, we got to know a little bit about lines, right? This has a slope of 600. This has a slope of 480. So in other words, I move over one, I move up 600 to plot the next point. Notice that's a pretty steep line, just like this one is here. So I can't really see those functions here, but I know that, if I'm on the blue, like if I'm on the red function, it lights up. It's in the screen. It's just almost a vertical line, or at least appears that way. It's not, but it appears to be. And this one's not even on the screen. Well, I know the y-intercept up here somewhere around 12,000. Okay. So what I'm going to do is, one of the things I can do is I can actually zoom out. And if I do that, you could see that, okay, I can see both of the graphs, the red and the blue, but it's still very distorted because the X is going from -5,000 to 5,000. So here kind of comes the function sense of, well, okay, it doesn't make any sense here to have negative products being made and sold. And I can't have 5,000. I mean, 292 is my maximum. So one of the things that I can do is start manually changing my window here, go to my graph settings. And again, I could start at 0 here. And I know I'm going to end at 292. Nothing makes sense beyond that. So maybe I'll go a little bit above that, like let's say maybe 350. And when I do that, now I can kind of see these graphs here. And you can still drag, to see those, but I still can't see the 12,360. So I got to get up a little bit higher than that. So what I will do now is I'll go back to this and start messing around with the Y values here. Again, 0, I'm not interested in, those things being anything less than 0, but maybe I'll go less than that, maybe like say -2,000, just so we still see the axis here. And I want to get way above 12,000. So maybe I'll go up to, I don't know, let's say maybe 25,000 just to kind of see what's going on here. And 25. So if I go to 25,000, no, that's not high enough. How about if I go up to, that was just 2,500. There's 25,000. I'm getting closer here. Okay. So maybe I'll come over here and change this to, let's say, 35,000. You can kind of see I'm kind of, eking my way up here. How about 45,000? Now I see where the cost and the revenue are going to get pretty darn close. Maybe I'll go up to, say, 55,000. And I'm getting tired of going this slow, maybe like 75,000, and bingo, there I am. So if I want to find the break-even point, that's actually where the and usually Desmos, if there's an intersection, it'll click right on it. At 103 units, my revenue is going to be $61,800, and my cost is also going to be $61,800. Okay, so that's where I'm going to break even. And then notice my revenue is greater than my cost for X beyond that. Okay, so in other words, I could go solely beyond that value there and, up to 292. And I'm going to be making money. Obviously, it would make sense here, if we kind of zoom out a little bit. You can see if I get over here to like 292, which would be, I don't know, right about here. You can see that, again, the profits keep separating further and further and further. Okay. Now, another way I could look at this is, let's say I just look at the profit function, which is the revenue minus the cost. And I could just type in an expression here. I could divide a new, function where I call P of X is, let me see if I can type that in here correctly, P of X equals, okay, the revenue minus the cost function, and let's say that one's green, that's my profit function. Notice it's going to be here, and that's the same thing over here. I also have a P of X here. I'm just going to call it Y equals. So I can, again, it'll still graph with just the expression. But this one here, if I turn this on, this is a purple graph. So you can see the purple and the green graph are the same. I can enter them either way. But the key is if I go down here, notice now I got a profit, right? At 103 units, my profit is 0. And that was the same point that I had up here at 130 or 103 units, the profit was equal to the cost. Okay. So I could go ahead and do all that. I probably should have on the paper just showed you algebraically, because you might look at that and say, well, wait a second, it would have been a whole heck of a lot easier just to set this thing equal to 0. And if you did do that and added 12,360 to both sides and divided by 120, you would have gotten 103 for your solution. Okay, and that would have been a lot quicker than going through all these graphs. But I think the graphs, again, illustrate the fact that, what we're going to be doing in calculus here is taking functions and analyzing them. These are mathematical models. This red graph models my revenue. The blue graph models my cost. The green or the purple models my profit. Okay. And so later on, we're going to get models that twist and turn and all that sort of thing, and profit functions that will go up and down. And we're going to be trying to find maximums and minimums and things of that nature. And that's what we're going to be using calculus for. But again, this is just a very basic intro of how to use functions for models. So I thought I would get into some of that other stuff, illustrate a few features of Desmos. And so if you did happen across this video, I hope it really helps you, and we'll be on to the next one.